All right. Well, I tell you what. Since Matt and Jared are not here to do the first problems, what we will do instead is give Matt and Jared harder problems when we... Oh, look, there's Matt.
Sorry, I'm late.
That is okay. All right. So what we're going to do today, I was just telling the rest of the class, is we're just going to do a little bit of reviewing because we do have a test on Tuesday, and I have a draft of the test. And since the camera's running so that Joe can hear it as well, I'll send you guys like once the final version of the test is made, I'm inclined... There's a handful of things that we did that we never came back to, like that business of using limits to actually formally define the derivative back in section 3.1. That business of using that fancy rule that was for figuring out the derivative of an inverse function. All those things are not that, we never came back to it. That's not the best use of our time. In contrast, for the rest of the semester, we're going to need to be able to use things like product rule and chain rule and stuff like that. I think it's better for us to do that. So, let's review a little bit of that, but kind of work on the assumption that the test is on Tuesday, and then the rest of the period we're going to be making sure everybody's got everything turned in as much as possible. We'll kind of take an inventory and, hey, wait a minute, get some of this done real quick so there's not blanks in the grading sheet. Alright, but we're going to have some folks come up here and actually do each one of these problems. How about Matt and Scott? Why don't you guys each come up here and do one of these two problems up here on the board?
I want to do the one on the left because I have a hard time with this one.
Alright. So come on up there and show. They are both examples of a product rule. Yeah, there should be plenty of pens. If they're not or something like that, let me know. Matt is doing his trick where it's 1d2 plus 2d1.
Do you do product rule on this one after?
I would say that this is a product rule where there's this times this. So you're going to have derivative of this times this plus this times the derivative of this. Let's see how that works out. Okay, so Matt said the first times the derivative of the second. Okay, so first times the derivative of the second plus the second times the derivative of the first, which seems fine. And then he has some simplification. And he could have simplified further, right? I mean, he could have taken this down to 3x, because one of those x's would cancel, plus 6x natural log of x. That looks right. Okay? Now, this for notation purposes, though, let's be clear about this. We would not have then said, like, equals, 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 right? I mean, this would have been like the derivative of f was equal to this, right? I mean, sometimes people are kind of tempted to just sort of like, it's all equal to each other. It's not. Okay? Good job, Matt. All right. Cool. Scott.
Longer than, so base it down?
No. Okay. All right. So
is
Actually, I want to do that one too.
well, you have one mistake right here. It's not x to the e, it's e to the x, right?
Okay.
So, okay, derivative of the first term, so this is your first and this is your second, right? Okay, so derivative of the first, derivative of e to the x is just e to the x, times the second, plus the first, which you wrote over here, times the derivative of the second, except it's actually, derivative sign is negative the cosine.
Okay.
Yep, and that's probably the most, well, actually in this case you probably can factor out your e to the x.
Yeah.
Yeah, that would be all you would need to do on this particular one, okay? And you would not lose points for not having done things like simplifying or whatever. That's not the point. Okay, so it looks like product rule problems kind of happened and that was a thing and so on. Hey, let's write some chain rule problems on the board. How about if I made up a chain rule problem here? How about f of x equals cosine of x plus the sine of x, the quantity squared, and f of x equals the cosine of x squared plus x plus 1. Alright, those are both chain rule problems. And we're going to have Jared and Jordan go up. And one will do one side and one will do the other.
Are you serious?
I am
I
serious.
can go up for them. I need practice.
What did you say?
I can go up for them
Sure.
because I need to practice.
Okay. I'm excited about that.
Because I understand it, but I don't do well in the class.
I understand. math on YouTube.
So channel alright, so that
Great. Do you see what she did here? So there was like an inside part, which she was just calling a. So this is like a squared. And then the derivative will be the derivative of that, a squared becoming 2a, times the derivative of that inside part. And then she did all that. And, oh, you might be tempted to expand that and try to simplify, but there's not likely to be anything all that great you can do to that. In this particular case, it might be that if you rearrange this, I wonder if you rearrange this, if you would get 2 cosine squared x minus sine squared x. Because wouldn't cosine squared plus sine cosine minus sine cosine? Yeah, I think you would actually. But anyway, I don't care. I wouldn't make you. All right, meanwhile, Max is over here. So good job, Jordan.
Yay.
All right. Derivative of cosine is negative the sine of the stuff on the inside times the stuff on that times the derivative of the stuff on the inside, which I like. I like what he did here. Now, here's the deal. He did do something that is kind of a bad habit. Notice how he has, I like what he wrote here better, where he's got parentheses around this, because without these parentheses around here, it would be hard to know, does this mean 2x times this and then you're adding 1? Or do you mean 2x plus 1 times this? So I like how you have it written here better. Okay?
but this is correct?
Yeah, this would be correct.
Oh,
Yeah.
cool, cool.
And honestly, most of the time we would pull this one that's kind of a coefficient out here in front. But again, that's not like, it's not like you're wrong. Okay? Good. All right. So that leaves, let's see, we've done chain rule and we've done product rule. And along the way I've been sneaky and slipping in things like power rule and trig rules for derivatives. So that really only leaves quotient rule. So Mr. Eric and Miss Jennifer will each have a quotient rule problem. How about x squared over x plus 2, and how about this one be e to the x over x squared plus x. Sure. 2 quotient rule problems. Here's one for you. Oh man, look at that. She's doing it all in that Leibniz notation. That gets pretty cool.
I always misplace my pen. Such pencil. What? Did you touch it?
What she did here was derivative of the first times second minus the first times the derivative of the second. Matt, is she right? Is it low D high on your little sing-song thing? Or is
Low,
it?
low D high minus high D low.
Yeah, okay.
Over low.
We're just re-emphasizing his little yodel there. Okay, so I think she has it right. I think we have a mistake happening here. Okay, so that's the problem. Okay, so I like what you had here. Now, when we do this though, the derivative would be, okay, it's low D high to use his notation, right? So it's the low part times the derivative, here, I'm going to do this here, the derivative of the upper part, right, minus the upper part, times the derivative of the lower part, all over the bottom part squared, which you had right. Okay, so after that, it's pretty much just, what's the derivative of e to the x? It's that astonishing one where the derivative of e to the x is e to the x. Right. And the derivative of x squared plus x? Just 2x? Yeah. Okay, cool. So this one was we just kind of got off on the wrong foot here with the order of the low-d high to high-d low thing, okay? Which, the more times I hear Matt say it, the more confused I get.
So they were kind of backwards.
Yes, you're going to have it backward. But you know what? It's open book, open note on the test, right? And so, I mean, worst case scenario, make yourself a table of your rules. Bring yourself a table of the rules from the internet, okay? Or whatever you need, okay?
I had to make a table, but it was on my snow days.
There you go. Yeah, okay, good. All right, so whatever those takes, that's fine. Now, there is one little thing just to be careful about here. I only noticed it because, you know, whatever, I'm nuts. On what Eric was writing here, do you see these little symbols he was using on his D's? That might be how Eric writes his D's, I don't know. But do be careful. Because while there is a d dx, like that's what we're learning about is these derivatives here, there is also partial x, and it's kind of a little curly d thing here. Okay, and we're not going to get that far this semester, but that's a calc thing. Okay, and so like a slightly curlier d might be like causing you trouble some fine day.
That's how I write my teeth.
Yeah, that's okay. Just, I mean, you know, being a little bit, like, recognizing that, like, my 8-year-old is learning cursive right now. And when they learn cursive, you know, they haven't learned letters since they were like 2. And the whole idea that you have to be careful about these letters annoys the crap out of them. You guys all learn cursive in school these days still, right? Right? So, like, when he was learning N or M, you know, he was just sort of getting kind of nuts as to how many bumps he would put on there. Okay? Whereas it clearly matters, right? When you're learning cursive, how many bumps to put on each one of the letters. In the same sort of way, whereas right now it might not seem like a big deal, there will be, the day is coming soon, sadly though not before the end of this course in May, where that will be a problem. Okay? So like when you're in college, you know, if they get a little farther than we did when you take Calc 2 or something in college, you'll discover, oh, that's a big problem. Just to be careful about that. Okay. Here's the deal. You guys all just demonstrated exactly the kinds of things that are on the test. In the current draft of the test, there's either 10 or 12 derivatives that are just exactly like this. They are mixes of some chain rule problems, some product rule problems, some trig rule problems. Most of the time there's a way to slip more than one thing in there, right? It's a trig rule problem that's got also a product rule in it or something like that, okay? They're not really that... How long was the longest person at this board right now? 4 minutes? Maybe? Right? I mean, realistically, doing like 10-ish of those problems shouldn't seem like the biggest of deal, but it spooks me a little bit. So probably what will happen is I will have some regrets, and either I will throw out a couple of those problems before I print it, or we'll make it so that, like, compute 6 of these 8 derivatives. Okay? That way if there's one that you're like, oh god, no, those exponential rules, I can't remember, you aren't sitting there staring at it for 10 minutes. Right? Okay, so one of those 2 things will happen. I haven't decided yet which. Okay, but I've written like, I don't know, 12 questions. There are also a couple of questions that are more like what Joe was asking about yesterday when we met, where it was the like, oh, here's some function, and at this point, what is the equation of the line that's tangent? And we certainly have practiced that quite a little bit. I mean, if you have, let's say this is the equation, that's going to be an x cubed kind of thing. How about x cubed plus 20x squared plus x plus 1? Okay, that would have the equation that makes that kind of zigzaggy thing like that. If that was your equation, and this point right here is 1 comma something or other, let's see, what would that something or other be? If it's on that graph there, x equals 1, what is y? This is 1 plus 20 plus 1 plus 1. So apparently this is at 1 comma 23. So then what would be the equation of the line going through that's tangent to 1 comma 23? Well, we would be using that, I mean, if this is our f of x, then our derivative of that, oh my gosh, these power rules are the easiest ones to do, right? 3x squared plus 40x plus 1. So, this is the derivative. So, at the point x equals 1, the slope of the line, the slope of the tangent line will be f prime of x when x is equal to 1. Or let's see, that'll be 3 plus 40 plus 1. So apparently it's 44. That's a very steep line. Alright, so then we use, okay, if this is x1 and this is y1, then our equation for this is y minus y1 equals our slope of our tangent line, x minus x1. So y minus 23 equals 44x minus 1. And then you could go ahead and simplify to your heart's content, as much or as little as you want. The simplification of this and rearranging it and so on is Mrs. Webster's Algebra 1 class, and I am assuming you can do all those things. I'm not that worried about it. There were also places like, what if I had asked, what are the values of x on this equation, where the tangent line is horizontal, or the slope of the tangent line was 0. Alright, what we would have done is, if this is the derivative, that's the slope of the tangent line, just set it equal to 0. Now, this particular one would require the quadratic equation to do. I would give you the quadratic equation if that was necessary. We're not here to have memorized that. Okay, that's again, that was like algebra, pre-calculus, and so on. The exact problem I'm thinking of in the current draft of the test, it's simpler than this. But you would get a value of x such that the tangent line there and the tangent line there is horizontal. That's a hugely useful thing because that helps you find the local maximum and the local minimum of the function, the local peak and the local dip. Okay? That's a very useful thing. In the current draft of the test, there is nothing like section 3.1. Section 3.1 was more of those limits and showing limits, how to use them to kind of derive what a derivative means. I don't even like saying that sentence because the word derive and derivative are too similar to each other. We're never going to see that again. We're going to be using these skills for the rest of the semester. I'm inclined to say there won't be anything like that, but I will send you guys an email with like either a review sheet or some practice questions or something, and I'll mention it. In the final version, 3.1 just isn't in there. That may not be the best way for us to use our time. I'd so much rather you know how to compute the derivatives. Okay? I'm not nuts about that section that was inverse functions. There was a nifty rule in like 3.5 or 3.6 that like if you knew f of x, how to get the derivative of the inverse of f of x. You might even remember it had some horrible notation where it was like the derivative of the inverse and all that kind of crap. I hated all that notation. And realistically, the whole reason they were doing that was to get us to what was the derivative of the inverse sine function, or the derivative of the inverse cosine function, and so on, which is not the most useful thing. Okay? I've been lately annoying the crap out of the trig students with all of the solar panel type stuff that my other classes at Creighton are doing right now, because that's all trig. Right? I mean, angles of the panels, and angle where the sun is. And even in all that stuff, we almost never use, well, we use inverse sine and stuff like that, but we almost never need to take the derivative of the inverse of the sine and so on. I mean, there ain't things that are all that much more trig-oriented than solar panels. And if even they aren't using it, that's not the most useful thing. So spending all that time on derivatives of inverse functions just wasn't the best use of time. Okay? Whereas if I had some other function, I mean, the same damn rule that they learned in that section, section 3.5 or whatever, works just fine if your function is 3x squared plus 1. You could compute the inverse function of this and then get the derivative. But you know what? Why not just do it that way? Just compute the inverse function and then take the derivative. The nifty trick doesn't help you that much. So we won't be doing that either unless I tell you otherwise. But at the present time, I think the test is long enough without it. Where I'm not entirely sure how I feel about it is implicit differentiation. Implicit differentiation, which was one of either the last or second to last section in and this is second to last in this chapter, I like it, and I think it's coming up again. But I think I'd rather have more review about it and like slip that onto the next test or something like that, okay? Because my feeling from like emails that I got and stuff like that was of all the sections in chapter 3, that was the one people were least comfortable with, and I feel like I didn't do that great of a job explaining it. So my gut reaction is the test is long enough, let's punt implicit differentiation to the next section. But we'll see. Again, I'll send you a review sheet or something like that that will tell you what the final answer on that is. Okay? If it is on the test, it's not going to be like the hardest implicit differentiation problem you did on homework. It'll be more like the easiest implicit differentiation problem on homework. Make sense? Okay, excuse me. I think you guys are going to be in good shape for this test. I'm not that worried about it. So let's spend the rest of the hour getting people's grades into my spreadsheet so that like this evening I can pop them all into RDS and we should be in good shape on that, okay? Because I want to see as many of your assignments as you've got, all right? I don't want to have to figure out some way to fill in gaps in the grading and so on, okay? All right, let me get this turned off.